Hey Algebra 1 students, I am in your workbook on page M1 138. Because of that super lovely fire drill that wasted a good chunk of our lives, we didn't get as far as I really wanted to, and I wasn't prepared to not get that far, and I'm so sorry. I will get Google Classroom updated with the slightly shortened assignment because I am asking that you finish these notes looking with me here. So again, page M1 138 is where I would like to be because I added on 3 questions, but I do want to add on one more. And it's really the same thing as before. How many home runs is not the 99th term this time, but let's talk the 57th term. And as I'm talking, if there's any point where you're like, wait, she's going too fast, I can't, this is a video. The nice thing is you can pause me at any time and get caught up. So I want how many home runs is the 57th term. So the way I'm going to kind of think about this, again, is with the chart. I'm going to erase those guys because they're in my way. And I'm talking the 57th term. So the 57th term is corresponding with a certain number of home runs. Remember that first term was no home runs. So it's kind of behind one. So there are 56 home runs represented in your 57th term. So understanding in the context of which term means what will really be essential when we talk about this explicit formula. So if you turn the page to page M139, I wrote out in class that our explicit formula is that any term can be found by your baseline amount, 125, plus 18 times the previous number of terms, n minus 1. So if I want 48 home runs, I scrolled too far, I actually asked you 48 home runs earlier. We said 48 home runs corresponded with the 49th term. So if I want the value of the 49th term, I take my initial amount of 125 and add on $18 donations, specifically 48 $18 donations, n minus 1, because there are 48 home runs and you get $18 every time there's a home run. So I'm just going to take 125 plus 18 times 48, which is equal to $989. So the last one here is 214 home runs, so I need to figure out my term amount. So I conveniently already have this table filled out. The number of home runs is not equal to the term number. You always have to add 1 to get to your term number here. So 214 home runs is your 215th term in that sequence. So A sub 215 can be found by your initial donation of 125 plus 18 214 times. Because that's how many home runs there are, that's how many 18s get added on. So this one's a lot more. $3,977 would be donated. So then the next one, it just slightly changes it up. It says Rico decides to increase his initial contribution and the amount donated per home run hit. He decides to contribute $500, and then he's going to donate $75 for every home run that they hit. So if I want the first 5 terms of the sequence, well, we're going to start with his donation. He's going to do this regardless of how crappy of a season they might have. But if I want the next term, I'm increasing by a constant of 75. That's what makes this an arithmetic sequence. So I'm going to take 500 and add on my 75. So that is my common difference. I'm going to take my second term and add on my common difference. This is more thinking of it recursively. Your previous term plus your common difference will get you your next term. What I want to point out about this is, again, that off by 1 relationship. So this is term 1, this is term 2, this is term 3, this is term 4, this is term 5. Term 5 was created by adding 75 4 times. So there are 4 donations, 4 increments of 75 for your 5th term. So this off by 1 relationship we saw here is still true in this instance. So when I want 39 home runs, I'm going to draw that table again. So I'm I can relate home runs to my term numbers, and I'm using shorthand out of laziness because the first term was before any home runs are hit. The second term is after 1 home run. The third term is after 2 home runs. So this question wants after 39 home runs. So the pattern is the term number is always 1 more than the number of home runs. So this is asking, well, what is your 40th term? So if I knew my 39th term, I can just use a recursive formula. I don't know my 39th term, so I have to use an explicit formula. The explicit formula says that we can find any term, so I'm just going to write A sub n, any term can be found by taking your initial amount, my first term in the sequence, 500, and adding on a certain number of your common difference. So the common difference was a 75. I need to add 75, but the number of times is going to depend on how many terms are before the one I'm on. In this case, the number of home runs. So this is my recursive formula, my explicit formula. So I can say my 40th term can be found by 500 initial donation plus 75 times 40 minus 1. The fact that 39 home runs represents this 40th term. So 500 plus 75 times 39 gives me a whopping total of $3,425 donated. So I kind of want to reverse this, and I know I don't have a ton of space, so I'm just going to scribble this out. And instead I'm just going to ask, what is the donation amount that is represented by the 84th term in the sequence. So basically, if you just kept extending this sequence out, when you eventually got to the 84th term, what would you have? Where would you be? And again, I don't really feel like going out 84 numbers, so I'm going to use the formula that I just created. I'm going to use this guy. But I need to be careful here. If I'm telling you the 84th term, it's working backwards this time. That means there have been 83 donations after my initial donation. There have been 83 home runs. It means I am finding A sub 84 because N is your term number. So before, the thing I gave you, you would change it by 1. Pay attention to what's given to you. Are you given a context thing of home runs, or are you given a sequence thing of the term value? So the 84th term would be $500 plus 75 times 84 minus 1. We need to say there are 83 home runs that have happened, so add on 75 83 times. So 500 plus 75 times 83. This term would be $6,725 after 83 home runs. It will be really easy to mix up terms and the in context things, especially once I ask you to do one that's not just a donation problem, because I feel like that's kind of what the book is focused on so far. But tomorrow we're going to get to more recursive and explicit, but then we're going to switch to, what am I trying to say? We're going to switch to geometric. So we're going to kind of hone down the assignment. All I want you to do is practice number 1 because we didn't have as much time to get through the notes, so I made you watch this instead. So you'll see Google Classroom updated in about 5 minutes after I finish this video to just practice number 1. Thanks, guys.